Dear students, in this session we will consider some of the extensions of money multiplier. Money multiplier can be extended in many directions depending on assumptions about deposits and also assumptions about reserves. Now, as in the previous session, we assume that monetary base B consists of currency plus reserves. Monetary base consists of currency plus reserves. And now we consider reserves as consisting of two parts. One is the required reserves, ER. One is the required reserve, it is denoted by RR, and the other one is the excess reserve, ER. Now the reserve is classified into three. One is required reserves, the other one is excess reserves. Monetary base or high powered money consists of currency plus reserves. And we also assume that commercial banks reserves, that is R, are a fixed portion R. R is a fixed portion R of what is known as total bank deposits. Reserves is a fixed proportion R of total bank deposits, which consists of demand deposits, time deposits, and government deposits. Consists of this demand deposits plus time deposits plus government deposits. In the previous example, we simply defined R, reserves, as a fraction of deposits, simply demand deposits. Now we consider it as a fraction R of demand deposits, total deposits, and government deposits. That is the difference. So that R is equal to R by dd, R is equal to again R by dd plus td plus dd, or R is equal to R by dd plus R into dd plus td plus gd. So R is equal to R by dd plus td plus gd. Now, the only difference which we make is reserves now consists of required reserves and excess reserves, and reserves itself is a fraction R of demand deposits, time deposits, and government deposits. Now, and as we have discussed in the previous class, money multiplier explains the relation between high powered money and money supply. It points out that a small change in high powered money, which brings about a change in money supply, which is much higher than the change in monetary base or high powered money. So we consider three models. We start with model 1. Remember this, reserves are now required reserves and excess reserves, and reserve and deposits now consist of demand deposits, time deposits and government deposits. Demand deposits, time deposits and government deposits. In the previous class, excess reserves were not considered. Also, no difference were made between these three types of deposits. Now, in the first model, money supply is defined as currency plus demand deposits, C plus DD. And C is currency held by the public, and it is, as we have discussed, an important part of monetary assets. And this can be expressed as a proportion K of currency of demand deposits. I simply changed the notation C by DD instead of C. In the earlier example, it was small letter C. Now it is taken as K. K is equal to C by DD. C by DD. That is the proportion of currency demand deposit ratio, C by DD. Currency deposit ratio, C. C by DD, or C is equal to K into DD. K is equal to C by DD, or C is equal to K into DD. Now, time deposits. Time deposits is not included in the definition of money supply. As we have seen, time deposits is not included in the definition of money supply. Time deposit we consider only money supply is currency plus demand deposits only. Time deposit is not. But still, commercial banks have to maintain a certain reserves to back up time deposits also. So, a certain proportion of the demand deposits is held to meet public demand for cash against time deposits also, even though it is not part of money supply. So, time deposits can be expressed as a certain proportion of TD of DD can be expressed as a certain proportion of demand deposit, or TD is equal to T into DD. TD. Also, in the definition of money supply, government deposits are not included, but commercial banks keep aside a part of their reserves, deposits, demand deposits, to meet withdrawal requirements of government also. We write it as G is equal to GD by DD, or G into DD is equal to GD. G into D, GD is equal to G into DD. Remember this, all these are expressed as fractions of demand deposits. Currency demand deposit ratio, total deposit demand deposit ratio, government deposit demand deposit ratio. Now, we express these relations as B is equal to C plus R. B is equal to C plus R. R is equal to R of DD plus TD plus GD. DD plus TD plus GD. M is equal to C plus currency plus demand deposits. Money supply is as usual currency plus demand deposits, and C is equal to K into dd. C is equal to K into dd. TD is equal to T into dd. GD is equal to G into dd. G into dd. So we have high-powered money, reserves, money supply, definition for C, definition for total deposits, definition for GD. Now we substitute these values. Now B is equal to C K into dd plus R into K into dd plus R into dd plus T into dd plus G into dd. Substituting the values. C equal to K into dd plus R into dd plus RT into dd plus RG into dd. Now I take dd out. dd into K plus R plus RT plus RG. D is equal to, and dd is equal to 1 by K plus R plus RT plus RG into D. Now we know that C is equal to K into dd. C equal to K into 1 by K plus R plus RT plus RG into D. Into B. This is B. Into B. Now substituting, we have M is equal to C plus D. C equal to, what is C? K by K plus R plus RT plus RG into B plus 1 by, what is K into dd? K into dd is, C plus dd. What is dd? dd is equal to 1 by K plus R plus RT plus RG into B. And solving, you will get M as equal to 1 plus K in the numerator divided by K plus R plus K plus R plus RT plus RG, or K plus R into 1 plus R plus G into B. Or we write M as equal to M into B. Now the money multiplier is M is equal to 1 plus K plus by K plus R into 1 plus R plus G. In the previous case, money multiplier M was equal to 1 plus C by C plus RD. C plus RD. Now we compare this. In the numerator, K is same as C. In the denominator, R is RD. If we assume that there is no 1 plus T time deposits, if we assume that there is no time deposits or government deposits, T plus G disappears, then we have 1 plus K by K plus R. The same money multiplier we have considered earlier. We will get the same money multiplier. And as we have discussed earlier, the value of M is proportional to monetary base, and it depends on these parameters K, R, T and G. As a numerical example, if we let K as equal to 0.25, R as equal to 0.1, T as equal to 1.4, G as equal to 0.1, we have the size of money multiplier as 1 plus 0.25 divided by 0.25 plus R is 0.10 into 1 plus 1.40 plus 0.10, that will give you value equal to 2.5. A 1 unit increase in the monetary base increases money supply by 2.5 times. This is the first extension of the money multiplier. First extension. The second and the third extensions will be considered in the next class.